Somewhere online right now, a headline is telling you that two of the most powerful telescopes humanity has ever built just independently confirmed something terrifying drifting through our solar system. As if the discovery happened moments ago, as if scientists are still scrambling to process what they just found. Here's the honest version of that story, stripped of the fake urgency, but keeping every genuinely strange detail intact. Because what James Webb and the Vera Rubin Observatory actually confirmed about this object doesn't need exaggeration to be one of the most remarkable findings in recent astronomy. It just needs the real timeline and the real science laid out properly. The object in question is called 3I Atlas, and the story of how it was found begins with a happy accident nobody planned for, followed by two much more deliberate rounds of scientific detective work that happened to converge, months apart, on the exact same answer. On July 1st, 2025, the NASA-funded Atlas survey, a network of telescopes designed to scan the sky for asteroids that might threaten Earth, spotted a fast-moving, faint object from its station in Rio Hurtado, Chile. Within less than 24 hours, NASA had confirmed what made this object different from the millions of asteroids and comets already cataloged in our solar system. Its trajectory was hyperbolic, meaning it was moving too fast, on too straight a path to be gravitationally bound to our sun. This wasn't a comet that had always belonged here, looping through some distant, elongated orbit. This was a visitor, an object that formed around a completely different star, in a completely different planetary system sometime in the ancient past, before eventually being flung out into interstellar space and drifting for who knows how many millions of years, until it happened to cross paths with our solar system. It became only the third such interstellar visitor ever confirmed, following 1I Oumuamua in 2017 and 2Is in Borisov in 2019. That alone would have been enough to make 3I Atlas one of the most important astronomical discoveries of the decade. What happened next, though, is where the story gets genuinely surprising, and where Vera Rubin Observatory enters the picture in a way nobody actually planned. At the time 3I Atlas was officially discovered, the Vera Rubin Observatory, a brand new, still not fully operational telescope perched high in the Chilean Andes, was in the middle of what astronomers call its science validation phase, essentially a structured series of test runs meant to calibrate the instrument before its real scientific mission began. As it turned out, purely by coincidence, Rubin had been pointing at exactly the patch of sky where 3I Atlas happened to be, days before anyone on Earth even knew the object existed. When astronomers went back through Rubin's archival test data, after the official discovery, they found something remarkable. The telescope had unknowingly photographed 3I Atlas as early as June 21st, 2025, a full 10 days before the Atlas survey ever spotted it. Digging further, the team recovered 49 total images of the object scattered across Rubin's commissioning data, 37 of which turned out to be usable for real scientific analysis, spanning observations from that June 21st sighting through July 20th. That serendipitous discovery mattered for a reason that goes well beyond bragging rights. Because Rubin's images predated the object's official announcement, and because Rubin's massive 8.4-meter Simone survey telescope, paired with its 3.2 gigapixel camera, the largest digital camera ever built, is capable of extraordinary resolution. Those accidental early images gave scientists something they wouldn't otherwise have had, a clear, high-resolution look at 3I Atlas from before its journey through our solar system had even properly begun. The images confirmed definitively that 3I Atlas possessed a coma, the fuzzy, glowing envelope of gas and dust that surrounds an active comet's icy nucleus as sunlight begins vaporizing material off its surface. In other words, whatever else 3I Atlas might turn out to be, it was, at minimum, behaving exactly like a comet, releasing gas and dust as it responded to the sun's warmth. The same basic physics comets in our own solar system follow. Rubin's early data even caught the object's coma actively growing between observations and detected a rare, sunward-pointing tail, a genuinely unusual feature caused by uneven anisotropic dust emission across the comet's surface, rather than the tail simply streaming away from the sun the way most comet tails do. Initial size estimates from those Rubin images put the object at roughly 7 miles wide, briefly making it the largest interstellar object ever observed. It's worth pausing on just how unlikely this accidental discovery actually was, because it says something important about why Rubin exists in the first place. The observatory wasn't even supposed to be doing real science yet when it captured those images. It was still working through its science validation phase, essentially the astronomical equivalent of a new car being put through test drives before it's handed over to its owner, checking that the cameras focus properly, that the telescope tracks the sky accurately, that the software correctly processes the flood of data pouring in every single night. And yet, purely because Rubin happened to be pointed in the right general direction during those tests, it captured the earliest, sharpest images of an interstellar visitor that any telescope on Earth would ever get. That's not a coincidence anyone could have planned for. It's a preview of exactly what Rubin was built to do once its real mission began. Watch so much of the sky so continuously that it simply cannot help but catch things other instruments would have missed entirely, sometimes even before anyone knew there was anything there to look for. Later analysis pushed that early picture even further into focus. As 3I Atlas moved past its closest approach to the Sun and began heading back out into interstellar space, astronomers were finally able to use Hubble Space Telescope observations from late 2025 and early 2026 to separate the faint, steady glow of the comet's actual solid nucleus from the much brighter, more diffuse coma surrounding it, the cloud of gas and dust that had made the object appear so much larger in earlier images. That refined analysis produced a new estimate, an actual nucleus roughly 2.6 kilometers across, with some uncertainty in either direction, making 3I Atlas significantly more massive than 2I Borisov, the second interstellar object ever confirmed, even though its visible coma had briefly made it look even larger than that in Rubin's early photographs. And crucially, despite passing close enough to the Sun to survive real thermal stress, the comet did not break apart during that pass, meaning scientists have been able to keep tracking the same object consistently across its entire visible journey through our solar system, rather than losing it to fragmentation the way some comets eventually succumb to solar heating. That's confirmation number one, independent, purely coincidental, high-resolution imaging from one of the most powerful ground-based telescopes on Earth, establishing that this ancient interstellar wanderer was a genuine, physically active comet, not some inert chunk of rock silently tumbling through space. Confirmation number two came from somewhere much farther away, and it took considerably longer to arrive. As 3I Atlas made its way through the solar system, reaching its closest approach to the Sun in October 2025 before beginning its long journey back out into interstellar space, NASA's James Webb Space Telescope turned its infrared instruments toward it, capturing what scientists described as the first mid-infrared chemical fingerprint ever collected from an interstellar object. Unlike Rubin, which primarily captures visible light and excels at wide, fast surveys of the sky, Webb specializes in something completely different, breaking down the exact chemical composition of distant objects by analyzing which wavelengths of infrared light they absorb and emit. Every molecule absorbs and radiates light at its own distinctive set of wavelengths, essentially a chemical fingerprint written in infrared. And Webb's instruments are sensitive enough to pick that fingerprint out even from an object as small and as distant as an interstellar comet passing through on its way back out of the solar system. In December 2025, as 3I Atlas began observations, delivered a striking result. The robust detection of methane in the comet's coma, a hypervolatile ice that only sublimates, meaning turns directly from solid to gas at extremely low temperatures. Finding methane at all was notable, since it meant the comet had managed to preserve some of its most fragile, easily lost ices across however many billions of years it had spent drifting through the cold vacuum between stars before ever encountering a sun warm enough to threaten that preservation. What came next was even stranger. In June 2026, a team led by researcher Martin Cordner at NASA's Goddard Space Flight Center published a peer-reviewed study in the journal Nature, built on Webb's detailed spectroscopic analysis of 3I Atlas using its NIR spec instrument, a spectrograph specifically designed to split incoming light into its full range of wavelengths for exactly this kind of chemical analysis. The study revealed a methane-to-water ratio in the comet roughly 11 times higher than any previously measured object in our own solar system, a genuinely unprecedented chemical signature. That ratio matters because it's essentially a snapshot of the conditions the comet originally formed under, frozen in place, and carried across the galaxy ever since. A methane-to-water ratio that far outside anything seen in our own solar system's comets suggests 3I Atlas crystallized in an environment with a fundamentally different chemical recipe than the one that built the planets, moons, and comets orbiting our own sun. Evidence, in other words, of an entirely different planetary system's chemistry, preserved and delivered directly into our own cosmic backyard. Based on that same data, scientists estimated 3I Atlas to be somewhere between 10 and 12 billion years old, meaning this object, currently drifting through our solar system, most likely formed before our own sun did. Our solar system itself is roughly 4.6 billion years old. 3I Atlas may have been wandering the galaxy for twice that long, a genuine relic from an era of the universe that predates the very star we orbit. Sit with that number for a moment, because it's easy to read past it without letting it land. Every comet and asteroid in our own solar system formed from the same swirling disk of material that eventually became the sun and the planets, meaning nothing native to our solar system can be older than the sun itself. 3I Atlas breaks that rule entirely, not because it's doing anything unnatural, but because it simply isn't ours. It's a genuine outsider, a piece of chemistry from a stellar nursery that may have finished its work and scattered its planets long before our own sun had even begun to condense out of its birth cloud. That's confirmation number 2, arriving via an entirely different scientific method, on an entirely different timeline, using an entirely different telescope, and landing on the same fundamental conclusion Rubin had already suggested. This is a real, physically active, chemically fascinating comet, unlike anything ever measured before, but a comet nonetheless, following the same basic physics every other comet in the observable universe follows. There's a third piece of independent confirmation worth mentioning too, because it directly addresses the part of this story that clickbait headlines actually want you to worry about. In February 2026, researchers using NASA's Swift Observatory reported something else unusual about 3I Atlas. It was releasing water vapor, detected through the faint ultraviolet glow of hydroxyl gas at a rate of roughly 40 kilograms per second, while it was still much farther from the sun than most comets typically begin actively releasing water at all. Comets in our own solar system generally don't start venting water in significant quantities until they get close enough to the sun for temperatures to reach the threshold where water ice sublimates efficiently. Catching 3I Atlas doing it from much farther out suggested either an unusually large reservoir of near-surface water ice, an unusually dark, heat-absorbent surface, or some combination of both, another small but genuine puzzle for scientists to work through, layered on top of everything Rubin and Webb had already found. That's an odd, genuinely interesting anomaly, the kind of detail that makes planetary scientists sit up and pay attention. And then, in June 2026, scientists at the SETI Institute, the Allen Telescope Array, a specialized array of radio dishes at the Hat Creek Radio Observatory in Northern California, at 3I Atlas, specifically to search for technosignatures, meaning any radio signal that might indicate artificial origin rather than a natural one. That search wasn't a token gesture. Interstellar visitors are, by their very nature, compelling technosignature targets, because an artificial object, however unlikely, would be one of the most significant discoveries in human history, and dismissing that possibility without actually checking would be bad science. So the SETI team checked, scanning a wide range of radio frequencies across the object's position. They found nothing. 0 detected signals consistent with technology, a result fully in line with everything Rubin and Webb had already independently shown. Unusual, yes. Ancient, yes. Chemically unlike anything previously cataloged, absolutely. But natural, through and through. Behaving exactly the way an old, well-traveled, chemically weathered comet should behave when it finally gets close enough to a star to start actively venting its ices into space. It's worth being upfront about where the word terrifying actually enters this story, because it isn't coming from NASA, Rubin, or the SETI Institute. It's coming almost entirely from one specific and genuinely controversial voice in this conversation. Harvard astronomer Avi Loeb, who has built a public following, speculating about the possibility that 3I Atlas, like the earlier interstellar object Oumuamua before it, might not be entirely natural. Loeb has published essays cataloging what he describes as roughly 22 separate anomalies in the object's behavior, from its unusual acceleration patterns to its size and composition, arguing these details are strange enough to at least warrant considering non-natural explanations. To his credit, Loeb has consistently framed this as a hypothesis worth testing rather than a conclusion he's certain of, and he's been explicit that the mainstream, natural explanation remains the most likely one. But in the retelling, especially online, that careful hedging tends to disappear, leaving only the headline-friendly version. A prominent Harvard scientist thinks this might not be natural. It's worth noting plainly that Loeb's position remains a minority view, not the scientific consensus. The overwhelming body of published, peer-reviewed research, including the Rubin imaging, the Webb spectroscopy, the Swift ultraviolet observations, and the SETI Institute's dedicated technosignature search, all converges on the same conclusion. 3I Atlas is a natural comet, its strangeness fully explained by the fact that it's simply older and more chemically unusual than anything scientists have previously had the chance to study up close. A separate documentary segment produced this past winter, featuring comet researcher Cyril Opitom, walking through the full body of available observations, point by point, opened with a blunt disclaimer that doubled as a spoiler. It's not aliens. That's not dismissiveness. It's what actually following the evidence across 3 independent lines of investigation using 3 fundamentally different instruments consistently points toward. Strange does not mean artificial, it means new. And on the subject of actual danger, the honest answer is straightforward. There isn't any. 3i Atlas made its closest approach to heading back out of the solar system ever since, passing near Jupiter in mid-March 2026 before continuing on a trajectory that will carry it out of our solar system entirely, never to return. Its path was never anywhere close to Earth. Every measurement scientists collected across every instrument that studied it confirmed a purely gravitational, purely predictable trajectory, exactly what you'd expect from a natural object obeying the same laws of physics as everything else in the universe. Whatever else 3i Atlas turns out to represent scientifically, it was never, at any point, a threat to anyone here. So why does this story genuinely deserve attention once you strip away the manufactured fear? Because what Rubin and Webb actually confirmed together, using completely different techniques on completely different timelines, is something far more interesting than a threat. Independent, converging proof that we just got an up-close look at a piece of another star system, one that likely predates our own sun by billions of years, carrying a chemical fingerprint unlike anything ever measured in our own solar system's comets and asteroids. Rubin's accidental early images gave scientists physical proof of cometary activity before the object was even officially known to exist. Webb's infrared spectroscopy, arriving months later through a completely separate scientific pipeline, gave scientists a detailed chemical signature suggesting genuine antiquity, an object that formed in a completely different corner of the galaxy, around a completely different star, at a point in cosmic history before our own sun had even ignited. 2 of the most sophisticated instruments human beings have ever built, using fundamentally different approaches, independently arrived at the same extraordinary picture. That convergence is also a preview of something bigger than 3i Atlas itself. Rubin's legacy. Survey of Space and Time, its official 10-year mission, which formally began on June 30th, 2026, is specifically designed to scan the entire visible southern hemisphere sky every few nights, cataloging millions of solar system objects and flagging anything unusual for follow-up study by more specialized instruments like Webb. Researchers analyzing Rubin's early data on 3i Atlas estimated that, over the full 10 years of that survey, the observatory could realistically discover somewhere between 5 and 50 additional interstellar objects passing through our solar system, a dramatic jump from the mere 3 confirmed so far across the entire history of astronomy. If that estimate holds up, 3i Atlas won't end up being remembered as some singular once-in-a-generation curiosity. It'll be remembered as the first clear demonstration of exactly how this new era of astronomy is actually going to work. Rubin sweeping the sky continuously, catching objects other surveys would have missed entirely, sometimes even before they're officially discovered, and then handing off the most interesting finds to instruments like Webb for the kind of detailed chemical analysis that can only come from staring directly, patiently, at one single target. So here's the real story once the fake urgency gets peeled away. 2 of humanity's most advanced telescopes did independently confirm something about the same object, S are implying. They confirmed that 3i Atlas is exactly what a careful, methodical, peer-reviewed scientific process should conclude about a genuinely strange visitor from another star system. Real, active, ancient. Beyond anything in our own solar system's history, chemically unlike anything catalogued before it, and entirely, unmistakably natural. It was never a threat. It was never heading toward Earth. And the researchers rushing to study it before it disappears back into interstellar space for good weren't racing against some hidden danger. They were racing against distance and time, trying to learn everything they possibly could from a piece of another solar system before it slipped past Jupiter, out past the edge of the dark it came from, never to pass this way again. That's ultimately what makes this story worth 3,500 words instead of a 30-second headline. Not fear, but scale. A comet that predates our sun by billions of years happened to drift close enough for 2 of the most advanced instruments ever built to catch it in the act. One by pure accident during a test run, the other through months of deliberate, careful spectroscopy, and both of them told the same story in the end. Somewhere out there, an old fragment of a long-gone planetary system is still tumbling through the galaxy, carrying a chemistry we'd never measured before, and for a few short months, it drifted close enough for us to finally take a good, hard look.